Okay, so today we're going to look at another example of a second order circuit, and this one is taken from the textbook example 7.10, sorry, example 7.11, that is 711, and this is the circuit that you'll be presented with, and the task is to find V0 here. So what we're going to do is we're going to write some equations defining the circuit. You can see we have initially this 12 volt source is connected to the circuit, and then it switches to the 24 volt, and we want to find what is the final voltage there, V0, when that switch occurs. So now let's look at just before that what is happening in the circuit, so we get some idea of what we should expect to get. So if we look at the circuit here, we could see if we connected to the 12 volt source for a very long time, it was connected like this from t minus infinity to t is equal to 0, t equals minus infinity to t is equal to 0, then we would have the inductor, the capacitor in steady state. So we could actually redraw this circuit with the inductor as a short circuit, the capacitor as an open circuit, and then we simply have a voltage divider circuit, and the voltage across here, which is V0, will be, if this is 12 volts, we would have an initial voltage of 2 volts, V0 at time 0 is equal to 2 volts, and I0 at time 0 is equal to 12 volts on 12 ohms, which is 1 amp. And similarly, when it switches, so this is our initial condition, sorry, this should be at t is equal to I0, and similarly when it switches to the 24 volt source, we will get the same thing. Inductor is a short circuit, then we have the capacitor as an open circuit, and we have the 2 ohm resistor. So we have 10 to, this time we have 24 volts, and since it's the same circuit, we should find everything is simply scaled by 2. So V0 at infinity should be equal to 4 volts, and I0 at infinity should be equal to 2 amps, and that would be the current coming in here. This is I0, sorry. Yes, so that is what we should expect to get. So we should see when we finally solve the equations, we should be able to get the voltages working out, the initial voltage being 2 volts and the final voltage being 4 volts. So let's go ahead and solve it, and we'll see if that is indeed what we get. So remember, these are the two steady state equations, so we're going to solve for what is happening in between these two steady states. So first thing we could do is we could write some equations defining the voltages in the circuit. So we want to find V0, so we know V0 is essentially 24 volts minus, this is when the switch has been switched now to this position, 24 volts minus the voltage across here, and the voltage across there, if this is I0 t, well, let's just call it I of it to make it shorter, it would be R1 it plus L1 di dt, right? And then we know that this it here is equal to the sum of the currents here and here. So we could write it in terms of V0, because we know the current through the capacitor is equal to C dV0 dt, and then the current through the inductor is simply V0 on R2. Yes, so if we combine these and I substitute the values, so I have IT in here, so I could substitute this entire thing here, and then I could differentiate it and substitute it here. What I would end up with when I substitute all the values will be a differential equation, d2v dt squared plus 7 dv0t dt plus 12v is equal to 48. So this is my differential equation. Now remember, this is no longer a homogeneous equation because I have this side is non-zero. So now I have to come up with a new equation, a new solution, a new general solution to this, and that will be the sum of the complementary and particular solutions, the complementary solution being the solution to the homogeneous equation, and the particular solution reflecting the form of the right hand side of the equation. So since it's a since this is a constant, that the particular solution will just take the form of a constant. And you could look at actually all the circuits you did before like this, with the constant simply being 0. So the particular, if I look at the roots here, if I solve, this is s squared plus 7s plus 12 is equal to 0. This will be the homogeneous part. If I solve for the homogeneous part of the equation, which is the characteristic equation, then I will get S is equal to -3 or -4, right? So now I could write my general solution, which will be V0t is equal to K1 e to the -3t plus K2 e to the -4t plus my particular solution. I'm going to add in K3. And again, you could look at even the solutions we did before, where we just had the homogeneous part of the equation. You could look at it in this exact same way, except the constant is equal to 0. So you could actually include this K3 in all of them, and in most cases the K3 will work out to 0 if you have just the homogeneous part of the equation alone. So now I have to solve for 3 constants instead of 2. Now the easiest one to solve for will be this K3. So K3, I have to look at my circuit. If I want to find K3, I'm going to look at when t is equal to infinity. When t goes to infinity, then I have V0t is equal to, this is going to go to 0, this is going to go to 0, so I'm going to get V0 infinity is equal to K3. And I know that V0 infinity, when I worked it out before, from the circuit, looking at the steady state values and so on, will be 4 volts. So I have my 4 volts there. Now to get the other initial conditions, I have to look at when t is equal to 0. So I'm going to look at t is equal to 0, and I'm going to get at t equals 0, let's look at it here, I'll get V0 is equal to, this is going to work out to 0, this is going to work out to 0, sorry, to 1 and 1. So I'm going to get K1 plus K2 plus 4. So So V0 at time 0, which if you remember, if we go back, was 2 volts. So I have now K1 plus K2 plus 4 is equal to 2 volts, or K1 plus K2 is equal to minus 2. So now I need to find what is dV0 dt at time 0. So I know that the current through the capacitor here is C dV0 dt, and at time 0 that is equal to the current here minus the current here. Let's call this current, that is the initial current, which we know because it is held constant by the inductor initially. It doesn't change instantaneously when the switch switches. So it is I0, let's call this I at time 0 minus V0 at time t on R2, which is 2 ohms, and the capacitor here is 0.25. So then I could work out, and I know this I0, this initial current, remember, was 12 before it switched to here, was 12 on 12, which was 1. So I have 0.25 dV0 dt is equal to 1 minus V0 V0 at 0 on 2. So V0 at time 0, if you remember, we worked it out to be 2 volts, which was here now 2. So I have dV0 dt, 0.25 dV0 dt is equal to 1 minus 1, which is equal to 0. So dV0 dt is equal to 0. And that makes sense because we have the capacitor here across it, which means the voltage does not change instantaneously. So the voltage, the differential of the voltage there is 0. So now I could write my equation, which is 0 is equal to minus 3 K1 minus 4 K2. And I have two equations now for K1 and K2. The first one being K1 plus K2 equals minus 2, and the second one minus 3K1 minus 4K2 equals 0. And if I solve that simultaneously, I will get K1 equals minus 8 and K2 is equal to 6. And that gives me V0t is equal to minus 8 e to the minus 3t plus 6 e to the minus 4t plus 4 volts. Now let's check and see what we get for the different conditions in our circuit. So at t is equal to infinity, we know that this will go to 0 and this will go to 0, and we'll get 4 volts. And that is right, because when we have the 24 volt source here, remember we'll have the voltage according to the voltage divider, 2 on 12 multiplied by 24, which will give us 4 volts. And for the initial voltage, we were supposed to get 2 volts, because then it would be holding the same voltage that was there when the 12 volt was just switched. So at t is equal to 0, we should get minus 8. V0 at 0, we should have minus 8 plus 6 plus 4, which is equal to 2 volts. So our circuit, our equation does give us a transition between the initial voltage and the final voltage. So that is always a check you could do to see if your equation at least makes sense. If it doesn't give you what the initial voltage was and what the final voltage is, then you know something went wrong in between.